There's a few things that are cool about this setup. Number one, Whisper is embedded and it's not talking to the cloud. So you could have your own embedded application for speech to text on your device and none of the data is sent to the cloud. It's all local dictation and translation. So that's number one. Number two, the EMMC flash here, this is storing the operating system. So notice here there's no SD card, unlike the regular Pi 4 board here, which has the SD card. So that's number two. So local operating system right here. And then three is I've usually used this little USB mic here in the port down here, or in past examples. But on this, I'm using the Braincraft hat here, and this has mics built in and a little audio codec chip. I'll show you. So you could design your own carrier board with that built in, with the mic and everything, and just have local speech to text on whatever embedded device you want to design. Alright, let's get to it here in regard to the EMMC and then the microphone. Inside this box is the Raspberry Pi 4 compute module with 4 gigs of RAM and 16 gigs of EMMC. And the EMMC is, I believe, a type of flash. You can boot from that as an alternative to an SD card. Here's the carrier board, and I've been trying to run Whisper C++. This 2 gigabyte RAM card here, the CM4 card here, struggled really. The main thing is if I try to run this and open up a if I try to run this and try to open up an internet browser, it would all freeze up. So even if you're not doing that, if you're just trying to run this board on some kind of embedded system, the 2 gig version is kind of the cutoff in my opinion, at least with the Whisper C++ model. I wouldn't really, I would start at the 4 gig model. If you power this on and don't have this jumper down here for the EMMC, then what you're going to get is a screen like this. I don't think this board came with the jumper, and if it did, I lost it. So what I'm going to do is use this instead. Alright, this is jumpered in the last column there. Power is applied and nothing now, and that's how it should be. Now what I'm going to do is plug in this USB cable here. This has micro USB on this end, and this is going to plug into the USB slave port. I'm going to also put some links in the description. Jeff Geerling did a really good video on this booting process. Note the D1 LED here is on. Also make sure you use a cable that you know works with data. I had to download this U-boot master zip file, extract it, and then I have to run this RPI boot setup as administrator. Extracting drivers, installing drivers. When all is said and done, this right here should act as a bootable USB drive, which we will then image with a Raspberry Pi operating system image. Alright, this is the part I didn't really understand at first, but now I get it. What you have to do is run this RPI boot application here. This app. This will take a minute, and your device, your CM4, will then appear as a drive. Here's the latest Raspberry Pi Imager v1.8.5, and now we can see the drive. This is what we want to mount the image to, And then we're going to choose our operating system. Go with this Bookworm. And then we have our device here. Alright, the imaging was just successful with the imager. It took about 35 minutes. The RPI boot tool ahead of that took about 5 minutes. So now what I'm going to do is unplug this. And then I'm going to pull the power, unplug this, the jumper, put the power back in. So now the operating system should boot up if we're lucky. And there we go, awesome. Just booted up a little while ago and then installed the GNOME system monitor with this single line in the terminal. And that installed just fine, so I can get a baseline now of the CPUs and memory. So we just have like one in the network, but I'm not really going to care about the network. It's mostly the CPUs that I'm going to care about. So the baseline CPU performance, we like peak around 20% here. Memory around 25%. As I've shown you in the other videos, it's going to be really similar. I'll put the links in the description for everything. So then we're going to copy this line, paste it in the terminal. So on and so forth. Just follow these instructions. Alright, I just followed the instructions. One thing to make sure you do ahead of time is to run this line here. Otherwise, you're going to have an issue when you're compiling make JStream. So do this line first. To run it, copy this line here at the top into the terminal, press enter, and here we go. Do we pick up on the microphone? Yep. Okay, good. It's working. Alright, it's doing okay overall. I'm not going to run the base model. I think the Tiny is all it can handle, just like the regular Raspberry Pi 4, 4GB. I'm not going to run the base. This can only handle really the Tiny. So I'm going to just stick to the Tiny on the CM4 edition. Sometimes it does max out all the CPUs though. Alright, we're at installing Blinka on Raspberry Pi here, CircuitPython on Raspberry Pi Linux. It says here this will work on any of the Raspberry Pis, even the compute modules. Alright, there's 3 lines here, so you copy and paste each line in the terminal and press enter. And there's a 4th line here. 3 more lines here. 7, and then these lines here. There's about 12 lines. 12 lines to enter. Alright, I just copy and pasted this line here. And it says I should receive a response like this. And here is the response I received. I have the I2C-1 here. Here's the microphone, the right mic, and then there's a left mic over here. Let's see if we can detect the voice card that these attach to here. So I'm going to type in this line. Good news, the I2C device was detected here, showing this 1A here at A10. Let's jump into the weeds a little bit now. I'm going to show you something that I think is a little bit interesting. On the Braincraft hat, there are two microphones. We have right mic here, left mic. These produce analog outputs here. This is our input one, left input one. So these are going to be inputs. They're outputs for the mic, and then they're inputs for this chip down here. Here's info on the WM chip. WM8960 stereo codec. So we have our analog inputs going to this chip. Next, what we need to do is configure the Pi to work with this chip. And to do that, we have to run some lines into the terminal here. And you can see right in here, WM8960. Things look good here. Everything installed. Time to reboot. To list our sound cards, type sudo aplay-l to list. And here we go. We have 3 cards, and this one at the bottom here, the Seed 2 voice card, WM8960. This is what we're interested in. And that's on the Braincraft here. Now I also have a USB mic. I'm going to try unplugging this and then seeing what happens. Hey, do we have anything here? Yes, it's working. All right. And here is the CPU usage. Thank you for watching, everybody. So it is possible to run Whisper C++ on the CM4 module, and you can also use other microphones other than the USB mic that most people use. The 4 gig is the minimum I'd recommend. The 2 gig doesn't really work, kind of just freezes up. Alright, take care everybody.